With this chapter, we're beginning our work in trigonometry. In trigonometry, we're going to be looking at angle measurement. Angles are measured in two different units, both degrees and radians. We're going to start by looking at degrees. Degrees can be expressed both as decimals and as degrees, minutes, and second, and this is called the DMS system. So a degree, 1 degree, is 1/180th of a straight line. And in the DMS system, degree, minute, second, we use units that we're familiar with in dealing with time. So each degree is subdivided into 60 minutes, and each minute is subdivided into 60 seconds. So the minutes is given with 1 apostrophe and seconds with 2. Let's convert 40.3472 degrees to degrees, minutes, and second. So starting off, we've got 40 degrees. And then we take the 3472.3472 and multiply that by 60. And if you do that on your calculator, you would find 0.3472 times 60 is equal to 20.832. So now we're going to take the 20. So it's 40 degrees, 20 minutes. We don't actually need the plus sign there. And then the 8.832 times 60 will give us the seconds is 49.92, and that's pretty close to 50 seconds, so we can round that up. So 40.3472 degrees is 40 degrees, 20 minutes, 50 seconds. Let's take that same number, 40 degrees, 20 minutes, 50 seconds, which is in the degrees, minute, second, and convert it back to the decimal. So we'll start off with the 40, and this time we do want the plus sign. When we were converting it from decimal to the minutes, we multiplied, so we're going to divide. There are 60 minutes in there. And on the seconds, we take the 50 and we divide it by 60 times 60. We're dividing it by 60 twice, once to get the minutes and then the minutes to the seconds. When you're doing this, if you are doing it by hand, what's going to happen is you have to be careful that we don't put down 1/3 and convert that to a decimal as 0.3. It's 0.3 repeating, and if you're using the calculator, you need to put in, if you put in 1/3, 1 divided by 3, you'll get a more accurate answer. And the same thing with the 50 divided by 60 times 60. Leave it in the calculator, it won't round it. Because when you make rounding in the middle of a problem, if we put this as 0.3 or even 0.33, we won't get it as accurate an answer. So when you put this in your calculator, 40 plus 20 divided by 60 plus 50 divided by 60 times 60, we get back to 40.34722, and it continues on. Try this. Try converting 48 degrees, 30 minutes, 36 seconds to decimal form, and then try converting 99.37 degrees to DMS form. Another unit of measure for angles is the radian. How big is a radian? If we have a circle, and we'll continue this circle around, and this is our radius, the arc that's the same as the radius is 1 radian. So we know that the circumference of the circle is 2 pi times the radius. So there are 2 pi radians in a circle. The circle is 360 degrees around. So it's 2 pi radians. Divide by 2. We get 180 equals pi radians. And 180 divided by pi is a radian. So we can use this to convert. Let's start with the second one here. How many degrees are in 7 pi radians? How many degrees are in 7 pi over 6 radians? We take 7 pi over 6. We know that a radian is 180 divided by pi. So we cancel out the pi's. We can reduce here. So this is 6 goes into 180 30 times. So 7 times 30 is 210 degrees. So 7 pi over 6 radians is 210 degrees. If we want to look back at the first one and convert from degrees to radians, we would do the opposite. So we'll start with 135 degrees, and we will multiply that by pi over 180. And this will give us pi over 180 times 135. This will reduce down to 3 pi over 4. So degrees will have the degree sign with it. Radians will have pi in its answer. If we want to find the length of an arc intercepted by a central angle of a quarter radian, the circle has a radius of 3 inches. We have an arc here, a circle with a pi wedge. We're trying to find this arc out here. We have a quarter of radian. We know that if we have 1 radian, that will equal 1 times the radius. If we have a quarter radian, it equals a quarter times the radius. And our radius is 3, so it's 1/4 times 3, or 3/4 inches. Let's find the perimeter of a 30-degree slice of a large 8-inch radius pizza. So we've got a slice of pizza here, and it's cut from a pie, pizza pie, so it's curved here. We want a 30-degree slice, and the radius is going to be 8 inches. We know that this arc here, we know that 360 times the arc is 2 pi times the radius. That would be the entire pizza. We only want 30 degrees, so it's going to be 360 divided by 30 equals 2 pi times the radius, and the radius is 8. We want to solve, first of all, for A, which is our arc. So we have 36 divided by 3, which is 12, which is 2 times pi times 8, which gives us 16 pi over 12, which gives us 4 pi over 3. That is just the arc. That's 4 pi over 3, plus we're looking for the perimeter. So we've got the two sides, which is our 8 and 8. So we get 8 plus 8 plus 4 times pi divided by 3. And 4 times pi is about 12 divided by 3 is about 4, which is, it's actually 4.2 plus 8 plus 8. So our perimeter is 20.2 inches. And finally, I just want to talk about navigation. If we're looking at the course or the bearing of an object, we are going from due north clockwise. So a 30-degree, well, let's go, a 90-degree bearing is going to look like this. This would be our 90-degree bearing. A 30-degree bearing would be something like that. And now, just for fun, a pie chart. See you in class.